Welcome again, Wildcats. All right, so today we're looking at Thursday, September 21st, graphing absolute value functions, and that's going to be on page 11. All right, so if you would, update your table of contents. All right, just so you know, I think I've caught the Wildcat sneezes, so I'm going to try not to sneeze during the video, but if I do, I apologize. So there you go. All right, so let's take a look at the notes. All right, so our graphing absolute value functions. Okay, so that's on page 11. All right, so we're going to start out with a little bit of absolute value information. Absolute value is the distance from zero, okay? This is why it makes the values positive. Okay, the function is f of x equals the absolute value of x. That's the parent function. The domain is negative infinity to positive infinity and bracket 0 to infinity for the range. All right, so absolute value transformations, okay? So first off, the parent function is absolute value of x here. Okay, just like now the notes before, now remember we use parentheses, but what I want you to understand is the same notes, okay? But instead of parentheses now, we have the absolute value symbols, okay? So when negative is on the outside of the absolute value symbol, it reflects over the x-axis. When a is greater than 1, it reflects, no, I'm sorry, it doesn't reflect. What is it I'm saying? When a is greater than 1, it's a vertical stretch, which we say VS. And if a is greater than 0 but less than 1, so vertical compression, VC, okay? All right. If there's a negative in front of the x inside of the absolute value, it reflects over the y-axis. If b is greater than 0, less than 1, so horizontal stretch. If b is greater than 1, it's a horizontal compression. If it's plus h, it translates left. Remember, it's opposite, right? If it's minus h, it translates right. And then if it's plus k, it translates up. And if it's minus k, it translates down. Okay? So if you would, go ahead and finish up notes, and let me just go back. I had my pencil in the way. Hopefully I didn't block things, but let me just kind of let you pause there if you need to, get those notes. And then we'll pause there if you need to. All right, so finish up your notes. Now, I noticed that I use colors because it's easier to see the connections from the picture if you have the colors. You don't have to, but I do recommend using colors for those, okay? All right, so with that, let's look at our examples. All right, so let's look at example 1 first. All right, so, excuse me. I know, put my nose real quick, but if you did get a cold, I recommend using the HEB tissues. They're the most inexpensive and the best. And you know, as they say, here HEB, or no, they say here everything is better. So HEB tissues, I recommend them. All right, but I apologize. All right, so example 1. All right, so first thing we're gonna do is graph it. Now, the way you do this is we can make a table, and let me get a ruler. Sorry to keep leaving there. All right, and so let's make a table of the parent function. So when x is negative 3, the absolute value of negative 3 is 3. When x is negative 2, the absolute value of negative 2 is 2. When x is negative 1, the absolute value of negative 1 is 1. When x is 0, the absolute value of 0 is 0. When x is 1, the absolute value of 1 is 1. And when x absolute value of 2 is 2, and the absolute value of 3 is 3. Okay? So we can graph the parent function of absolute value of x. So that's negative 3, 1, 2, 3, 1, 2, 3, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, 3, 3. Now, the reason why example 1 is the parent function is because I want you to understand that these are x and y points, but they're also directions. No matter where we transform or move this absolute value function, the directions are always going to be negative 3, 3, negative 2, 2, or left 2, up 3, left 2, up 2, left 1, up 1. There's your vertex, right 1, up 1, right 2, up 2, right 3, up 3. So it's important we're going to use these directions to move the other the transformational or the absolute value transformation, okay? All right, now domain from left to right, it is negative infinity to positive infinity. Range from bottom to top, it starts at 0, it includes 0 because there's a solid dot there, and it goes to infinity. Now remember, no matter if we transform the absolute value, the domain and range are always going to be in this format. Domain is always going to be negative infinity to infinity. Range is always going to be some number to infinity, okay? So if you would, go ahead and get example 1 down. All right, so let's take a look at example 2. All right, so example number 2. The first thing you want to do, okay, in transformation is you're going to move the vertex. Well, the vertex we know starts at 0, 0, right? So here we have plus 3. That tells us we move the vertex up 1, 2, 3. Okay? Now, from there, yes, this is x and y, but we can also say that these are the directions. Okay? These are the directions. So we know from this point we go left 1, 1, 2, 3, up 1, 2, 3. Left 2, up 2. Left 1, up 1. Right 1, up 1. Right 2, up 2. Right 3, up 3. And you'll notice it has the same shape. And the reason why it has the same shape is because it has to have the same directions. These directions make the shape of the absolute value, okay? All right, so the transformation is up 3 units. And then domain is, well, we know negative infinity to positive infinity. And then the range is, in this case, 3. So bracket 3 to infinity. Now remember, as we're doing this, and this goes for if you're a parent watching or a student watching, if you get it, I want you to write it down. But if you had some questions, you might write a little question by, like, say, transformation. You didn't know what transformation. So you might explain more, a little note there, or like didn't understand domain and range. So if you didn't get that, that's okay. Because remember, I'm gonna go back over these examples in class as needed. Okay, so just remember that. Okay. All right, and so let's look at one more example. All right, so let's look at example 4. All right, so example 4. So first things first, we know that the vertex is 0, 0. So the transformation. So the plus 3 means we move left 1, 2, 3, and the minus 3 means we go down 1, 2, 3. The reflection will be taken care of with the directions, okay? All right, so what we need to do is graph by direction. So we're going to make a direction table. So just left 2, up 2, left 1, up 1. This is your vertex, HK. All right, now the negative on the outside affects the y values. So we're going to multiply the directions, the y direction, by negative 1. Now, on the move the monster, some of y'all made a mistake when you did this. You can't just write times -1. You actually have to get the actual value here, okay? So 2 times -1 is -2. 1 times -1 is -1. 1 times 1 is 1. 2 times I'm sorry, 1 times -1 is -1. 2 times -1 is -2. Okay? So now our directions, we go left 2, down 2, left 1, down 1, right 1, down 1, and right 2, down 2. And you can see that we knew that the negative was going to reflect this over the x-axis, but by doing that, it changed the y value so that it would happen, okay? All right, the domain, again, from negative infinity to positive infinity. Now, because this graph reflected, okay, instead of going to positive infinity, it's actually going to negative infinity. So it's -3 to negative infinity. And then the transformations are reflect x-axis, see left 3, and then left 3 units, and down 3 units. Now I believe one of the moms at an open house mentioned about, hey, can you do one of the more difficult problems in the videos? And this is kind of entering to that. That's why I did example 4. Example 4 and 5 are the ones that students will probably have the most questions on. And so I understand. I especially understand if students want me to go over example 4 again in class. But I did that so they could see that, kind of get the motion of understanding of example 4. But I understand if there's going to be a lot of questions on example 4. And example 5, I definitely want to leave for class because there's definitely be questions, and I'd rather leave that for class. But again, I'll still go over example 1 and 2. I'll go over all the examples that's needed. Okay. So that should set you up. Just remember this point, students, if you watch this and you understand, feel free to finish the example of any assignment. But if you don't understand that, we're going to start with examples in class tomorrow. So with that, have a wonderful Wildcat day.